Hello Newton's fans, and welcome to a simple explanation of Newton's laws of motion. If you're having troubles, then I guarantee after watching this video, your problems will vanish. So, here's Newton's first law of motion. An object at rest will stay at rest, and an object in motion will stay in motion at constant velocity, unless acted upon by an unbalanced external force. The principle of Newton's first law is true on all balanced forces. Let's just take a simple example of a table at rest. The force of gravity is pulling the table downwards. This is balanced by the ground pushing equally upwards on the table's legs. Both forces are equal in magnitude, and hence the table remains at rest. Newton's first law is also known as the law of inertia. Inertia refers to the tendency of an object to resist change in its motion. This basically means if an object to remain still or in constant velocity, it has inertia. In order to overcome inertia, an unbalanced force must be applied. John decides to suddenly push the table, eventually causing it to move. John eventually accomplishes the mission of changing the inertia of the table by applying an external force of 400 newtons. The acceleration of a body depends directly on the size of the unbalanced force, and inversely on the mass of the body. This is known as Newton's second law of motion. Newton's second law basically states that if the force increases, then the acceleration rate will also increase. However, if the mass was to increase with the same force being applied, then the acceleration rate will eventually decrease. This can be summarized using the equation F equals to ma. So what does Newton's second law mean? Well, let's say Susan decided to help John push the table with a mass of 25 kilograms. Consequently, the force would increase and double up to around 800 newtons. This would also mean the table's acceleration rate will also double up. Hence, the acceleration rate will be 32 per meter second squared. In this example, larger mass would mean larger inertia, so you need to apply a larger force to move the heavier table with a mass of 50 kilograms. Now, here's where Newton's third law comes into play. Well, it's simple. It states that to every action, there is an equal but opposite reaction. So what does this action versus reaction force really mean? Let's jump back to where the table was at rest. In order for the table to remain at rest, a gravitational pull of 500 newtons was equal to the upward push of the ground on the legs of the table. The force exerted is the action and the force experienced as a consequence is a reaction. So in this case, the gravitational pull is the action and the ground pushing upwards is a reaction. As a result, the table remains stationary as both opposite forces act together and prevent the table from sinking into the ground.